Good morning, students. Welcome in new lecture of Math F242 Operation Research. Presently, we are doing game theory. So, I have given you idea about how to write the game problem, 2% zero sum game. Then, then what is the payoff matrix? Then, how to determine the solution for the pure strategy problem and mixed strategy problem. So, in continuous of that, let us have this problem. In this problem, you will understand how to write the payoff matrix. So let us have this question. Two companies promote two competing products. I believe audio video is okay.
Yes, sir.
Yes, sir.
Two competing products. Currently, each product controls 50% of market. Because of the recent improvement in two product, each company is preparing to launch an advertising campaign. If neither company advertises, equal market share will continue. If either company launches a stronger campaign, the other is certain to lose proportional percentage of its customer. A survey of markets shows that 50% of potential customers can be reached through television, 30% through newspaper, and 20% through radio. So first we have to formulate the problem as a 2% zero sum game and select appropriate advertising media for each company. Then determine the range of the value of the game. Can each company operate with a single pure strategy? So here we have the two company producing the particular product and they want to promote their product on the different media, advertising media. So it is given to you. Let us define. We have the for each company we have the following strategies. For the both company we have following strategy. Let us we denote the first strategy by one, no campaign by any medium, no campaign. Then two, with only TV. Three, third strategy means advertisement through newspaper only. And four, represent the radio. Five, represent TV plus newspaper. Six, TV plus radio. And seven, radio plus newspaper. And strategy 8 can be TV plus radio plus newspaper. So there are total 8 strategies for both companies to advertise their new product. So in this case, if you want to write the payoff matrix, so payoff in each additional percentage, payoff is the additional percentage of the customer reached by the company. So let us say on this side we have the strategy for the company A, and on this side we have the strategy for the company B. So company A's strategies are 1, 2, 3, 4, 5, 6, 7, 8, and B's strategies can be 1, 2, 3, 4, 5, 6, 7, 8. So if both company uh, do not campaign the product one and one, it means they cannot attract any extra customer. So extra customer will be the here zero. If company A use only, if the company A does not campaign and company B use TV, company B uses TV as a advertising medium, so it attracts the 50% customer. So when we are writing the payoff matrix for the company A, so we for the company A there is the loss of the 50% customer. If company B uses only the newspaper, only the newspaper Third one, only newspaper, so it can attract 30% more. So it means there is the loss of the 30% customer from the company A. So here we have the minus 30%. If the company B use only radio, so there is the gain of 20% customer for the company B, that is loss of 20% customer for the company A. So it will become the minus 20. If the company B use, right, company B uses, if the company B uses TV plus newspaper, so TV plus newspaper, if company B uses the TV plus newspaper, so total attraction will increase by 80%, 50 with TV, 30 with newspaper. So that is there is the loss of the 80% customer for the company A. So it is the minus 80. Similarly, if company B uses only TV and radio, so it can attract 70% more customer. So more customer means it is the loss for the 70% loss for the company A. And if that company B use is only TV and radio, newspaper and radio, so total increase in the customer will be 30 plus 20, that is the 50. That is the loss of the 50% customer for the company A. So here we have written the minus 50. And if the company A is not advertising or not using any campaign media, and company B is using, all the three medium, so 100% customers will be attracted by the company B. Means there is a loss of the 100% customer for the company A. So it is the minus 100. Similarly, if the company A use only TV, if company A use only TV and company use no campaign, so company A can attract 50% customers, right, from the B. So there is a gain of the 50% customer. If both company use TV, so both can attract the 50-50%. It means there is no increase, no loss. So that's why there is no gain, no loss for the company A. If company A is using TV, but company B is using newspaper, so uh, with this we have the 50% increase. With this we have the 30% increase. So net increase will be the 20% only for the player A. So that's why here we have written the 20. If company A is using only TV and company B is using only radio, so with the radio we have the 20% increase, with the TV we have the 50% increase. So net gain by the company A will be the 30% more customers. And in the similar fashion, if you take here the player B is using TV and newspaper, but player A is using only TV, so there is a net loss of the 30% customer for the company A. So similarly, we write all the payoff matrix, right? So this is the formulation of the payoff matrix. So from here, if you compute the row min, so row min will be the minus 100, minus 50, minus 70, minus 80, minus 20, minus 30, minus 50, and 0. And here when we compute the column max, so column max will come 100, 50, 70, 80, 20, 30, 50, 0. So from the row min, this is the max min. This is the max min, and this is what? It is the min max. It is min max. So here you can say that max min is equal to min max is equal to 0. That is equal to value of the game. So value of the game will be the 0, means no company Means both company, what is the optimal strategy? For the company A, strategy will be the 8, optimal strategy is 8, and for the company B also, optimal strategy is strategy 8. So it means what is your recommendation? Both companies should use all the three media, right? All the three advertising media. What is the net value of the game? Net value of the game will be the zero. Means no company can attract any customer, because both company are using the optimal strategy, for means optimal strategy, that includes that includes TV, newspaper, and radio, all the three medium. So there is no net change in the number of customer. So that is the game problem. So here the game has the saddle point. When we have the saddle point, then we say it is the pure strategy problem at 8 comma 8, meaning that both companies should advertise in all the three media. The game is fair. When the we say the game is fair, when the value of the game is equal to zero, because its value equals to zero. So in last class, I have started the solution for the mixed strategy problem, and we have done this question. Now, if we have the second question, solve the following games graphically. The payoff of player A is given to you here. So in this case, player A player A has the three strategy: A1, A2, A3, and player B has only the two strategy. So as I have told you, for the graphical solution, either player must have only the two strategy. Then only you can apply the graphical solution. So payoff for the player A is given to you 586557. 586557. So it is given to you 58 6557. Let me confirm. Yeah, 586557. Right. So this is the so for the graphical solution, there must be two strategy for either player. Then only you can apply the graphical solution. So here we have the two strategy for the player B1 and B2. So for the solving this type of the question, first we have to check whether it is the pure strategy problem or the mixed strategy problem. So for that, first we compute the row mean. So row mean is the 5, row mean is 5, row mean 5. And here we compute the column max. So column max is 6, column max is 8. So it is what? It is the min max, and all these are what? All these are the max min. It means min max is not equal to max min. Min max is not equal to max min, implies mixed strategy problem. Mixed strategy, mixed strategies problem. So when we have the mixed strategy problem, I have told you always the value of the game lie between max min less than equal to value of the game less than equal to min max. So here the value of the game lie between the 5 to 6. 5 to 6. Now how to compute the optimal or means how to find the optimal solution for the mixed strategy problem? For that, we assume let y1 comma y2 be associated probabilities corresponding to corresponding to player B's pure strategy B1 and B2 respectively, right? Similarly, let x1 x2 x3 be associated probability corresponding to player A's pure strategy A1 A2 A3 respectively. So here what we have, here we associated probabilities are x1 x2 x3. Here associated probabilities are y1 y2, such that such that y1 plus y2 is equal to 1, such that x1 plus x2 plus x3 is equal to 1. So as we have written y1 plus y2 is equal to 1, right? y1 plus y2 is equal to 1. This implies y2 is equal to 1 minus of y1. So here we have a1 a2 a3. This is the payoff matrix. Here we have the b1 b2, and entries are 5 8 6 5 5 7 5 8 6 5 5 7. So here what we have, the associated probability x1 x2 x3. Here the associated probability are y1 y2. So corresponding to A's pure strategies, A's corresponding to A's pure strategy. What are the A's pure strategy? It can be the A1, it can be the A2, it can be the A3. What will be the expected payoff? Expected payoff for player, right? For player B, right? So what will be the expected payoff for the player B? It will become the value into probability 5y1 plus 8y2 6y1 plus 5y2 5y1 plus 7y2. And y2 is what? It is given to you 1 minus y1. So 5y1 plus 8 1 minus y1, 6y1 plus 5 1 minus y1, and 5y1 plus 7 1 minus y1. So what will be the expected payoff? Expected payoff will become 5y1 plus 8 minus 8y1. So it will become the minus 3y1 plus 8, right? It will become the minus 3y1 plus 8. Then 6y1 plus 5 minus 5y1. So it will give you y1, 6 minus 5, y1 plus 5, y1 plus 5. Then 5y1 minus 7y1 means minus 2y1 plus 7, minus 2y1 plus 7. So these are the expected payoff corresponding to A's pure strategy. So when we draw the graph for this, so we know that y1 is what? It is the probability. So its value lie between 0 and 1, right? Here we have the it is the graph between the y1 and value of the game. Value of the game can be negative, positive. So let's say 1, 2, 3, 4, 5, 6, 7. Here we have the 1, 2, 3, 4, 5, 6, 7. Then here minus 1, minus 2, minus 3, minus 4, minus 5, minus 1, minus 2, minus 3, minus 4, minus 5. So now you draw one by one. So corresponding to A1, we have the expected payoff minus 3 y1 plus 8. So when y1 is equal to 0, it is the 8. So it is the 8. And when the y1 is equal to 1, it will become the 5. So 1, 2, 3, 4, 5. So it will become 5. So here we have the line of the expected payoff corresponding to A1. Then after we have the y1 plus 5. So when y1 is 0, it will become the 5. 1, 2, 3, 4, 5. This is the 5. When y1 is equal to 1, it will become 6. It is the 6. So here we have the line corresponding to the pure strategy A2. Then we have minus 2 y1 plus 7. So when y1 is equal to 0, this is the 7. When y1 is 1, it will become the 5. So let's say 1, 2, 3, 4, 5. This is the 5. So here we have the line of corresponding to A3. So it is the expected payoff. Means here we have written the expected payoff corresponding to pure strategy A1 as a minus 3 y1 plus 8, y1 plus 5, minus 2 y1 plus 7. So what we have to take here? We have to take the column max and then we have to take the min. It means from here we have to compute the min of max. So min of max means we have to determine the upper envelope. Upper envelope means with which two line or more lines you can make the upper envelope. So this is the upper envelope, and for the upper envelope, here this is the point where we have the minimum value. From the up for the upper envelope, at this point we have the minimum value. So this point will give you the min max, right? This point will give you min max. So here, and the this point is nothing, it is the intersection of line corresponding to A1 and corresponding to A2. So when we have the, so you can determine the easily intersection point, because you are getting this point as an intersection of A1 plus A2 plus A2. So when we equate the equation of A1 and equation of A2, you will get the intersection point. So this will come 4y1 and 4y1 is equal to 3. So y1 will come 3 by 4. So as the y1 is coming 3 by 4, this will give you y2 as a 1 minus of y1, that is the 1 by 4. So when we say y1 and y2 is equal to 3 by 4 and 1 by 4, and you have seen this optimal, what is the optimal strategy in the game problem? If for if for the player B has two optimal strategy with probability 3 by 4, 1 by 4 respectively, then player A also has the two optimal strategy, and what can be that? That will be the that will be the strategy which form the upper envelope, right? That form the upper envelope means it is the uh, it is the corresponding to A3 and no, A2 and A1. So when we have the A2 and A1, so it means automatically X3 is equal to 0. So when we have this matrix, payoff matrix 5865, 586557, here we have the A1, A2, here we have the A3. I'm saying that X1, X2, and here we have the X3. Here we have the B1, B2, corresponding probabilities are Y1, Y2. So if I'm saying that, let's say X3 is equal to 0. Since since A1 and A2 form upper envelope, form upper envelope, right? Upper envelope. So, so x3 is equal to 0. When the x3 is equal to 0, it is given to you x1 plus x2 plus x3 is equal to 1. So this implies x2 is equal to 1 minus of x1. So now B is pure strategies. B is pure strategy. B is pure strategy and age expected payoff. Age expected payoff. So B is pure strategy can be the B1 and B2. What will be the age expected payoff? Age expected payoff can be the 5x1 plus 6x2 plus 5x3. And corresponding to B2, it will be the 8x1 plus 5x2 plus 7x3. Right? So which can be written as 5x1 plus 6 1 minus x1 plus 5 into 0, 5 into 0, and this can be written as 8x1 plus 5 into 1 minus x1 plus 7 into 0. So the first, so the first will give you, first will give you 5x1 plus 6 minus 6x1. It means it will be the 6 minus x1. And second will give you 8x1 plus 5 minus x1 means it will be the 3x1, 3x1 plus 5, 3x1 plus 5. So here we have the two line only. So need not to make the graph. Just if you equate this, it will give you the point of intersection. So this will give you 4x1 and it is the 1, it is 1. So x1 will come 1 by 4. So when the x1 is equal to 1 by 4, so x2 will come 1 minus of x1, that is the 3 by 4, and x3 is what? It is the 0. Hence, and one more thing before that, hence the value of the game, value of the game you can compute by by any equation, right? All are the expected payoff only. So by any, if you want to write, so here either here the y1 is given, y1 we have computed as a 3 by 4. So when we put the 3 by 4 in any equation, right? So minus 3 y1 plus 8. So here value of the game will be the minus 3 y1 plus 8, this only, yes, or or y1 plus 5, and y1 is what? 3 by 4. So when it is the 3 by 4, so minus 3 by 4 plus 8 or 3 by 4 plus 5. So it is the minus 9 upon 4. So 32 minus this. So it is the 23 by 4. Or it is also giving you the 23 by 4. So by any one equation, you can compute the value of the game. So it means, so what will be the optimal strategy? So for the player A, right? Player A, x1, x2, x3. So what is the x1? X1 is 1 by 4, x2 is 3 by 4, and x3 is 0. So 1 by 4, 3 by 4, and 0 is optimal strategy, optimal strategies for for player A. And what will be the optimal strategy for the player B? What is the y1 y2? Y1 y2 we have computed as a 3 by 4, 1 by 4. So you can say here 3 by 4, 1 by 4 is optimal strategy for player B, and value of the game, value of the game is equal to 23 by 4. So this implies player A win by the amount, by the unit 23 by 4. So in this way, we can determine the optimal solution for the mixed strategy problem. So first we have to verify. So when we have two strategy for the player A, two strategy for the player A, then we use lower envelope. When we have two strategy for the player B, then we use upper envelope, right? Then we use the upper envelope, and you can see the from the graph, the value of the value of game is coming as a 5.75, which is between the 5 and 6. So in this way, we compute the optimal solution for the mixed strategy problem. So here you have seen we have the limitation. We have limitation for using the graphical solution, that either player must have only two strategy, right? For example, in the first problem, player A has the two strategy. Player in second problem, player B has the two strategy respectively. But in actual, it is not so. If it is not so, so directly we cannot apply the graphical solution. But sometimes we can apply the graphical solution also by reducing the payoff matrix size. If we have the more alternatives, right? If we have more than two alternatives for both players, so sometimes, not always, but sometimes we can we can reduce the size of the payoff matrix, right? We can reduce the size of the payoff matrix if any player now or updated strategy are only two, then you can apply the graphical solution. So what is that property? That is the dominance property. So with the help of the dominance property, you can reduce the size of the problem. So what is the dominance property? So only the first three we will use. If all the elements of the row, say the kth, are less than equal to corresponding to element of any other row, say rth, then the kth row is dominated by the rth row. The thing is what, when we have the payoff matrix. This is the kth row, this is the rth row. Let all the entries, let's say a1, a11, a2, a21, an, an1. So let's say all the entries of the kth row, a1, a1 less than, a1 less than, a11, a2 less than, a21, an less than, an1. So actually, in pure strategy, what we have to compute here, we have to compute the column max. if all the entries of this row, of all the entries of this row are less than the entries or element of this row, right? Rth row. So naturally there is no chance for the column max, right? For this row there is no chance for members, for the member in column max from this row. It means if you delete this row, there is no problem in the question. If you omit this row, there is no problem. So always omit such row. Uh, so as you omit, automatically your payoff matrix size will reduce. Similarly, second point, if all the element of a column say kth are greater than equal to corresponding element of any other column say rth, then the kth column is dominated by the rth column. So what is given to you here? In this case, again we have the payoff matrix. Let's say kth row, let's say rth row. So let's say it is the a1, a2, an. Let's say a11, a21, an1, and here we have to compute the row min. So if the a11 greater than a1 greater than a11, a2 greater than a21, an greater than or greater than equal to, here also we have the greater than equal to. So greater than equal to a n1. So naturally there is no chance, right, to be a row min from this column. From this column there is no chance to be a row min. So in that case we can omit this column, we can delete this column, and after the deletion of the column you will get, right, the reduced matrix. So it is given to you here, or omit dominated rows or column. So this will help you to reduce the size of the payoff matrix. Let us have this question. Player B has the four strategy b1, b2, b3, b4, and player A also has the four strategy a1, a2, a3, a4, and payoff matrix corresponding to player A is given to you, right? All the theory we are developing here for corresponding to payoff matrix of the player A. If you're writing the player B matrix, then you have to apply, then we have to alter some theory, right? So accordingly you have to change your theory. So it's always better you use only the player A matrix so that there is no confusion. By chance in exam, if you have player B matrix, so intelligence is that you transform that payoff matrix for the corresponding to the player A, so that the known theory you can apply directly. So here we are talking, in this question we are talking about the dominance property. So from the observation, if you will see, right, if you will see from the observation, if you will see entries of row 3, entries of row 3 means 2, 2 is less than 2, 2 is less than 3, 2, 1 is less than 3, 4 is less than 5, 0 is less than 2. So when we have to compute the column max, so naturally there is no chance, right, to be a column max from this row. There is no chance for the column max, from this row. So what we can do here, we can write row 3, all the entries corresponding, all the corresponding entries of row 3 less than equal to row 4. So it means row 3 is the dominated one, so we can omit the row 3. So when we omit the row 3, Now the player A has only three strategy, and player B has the four strategy. Now, if you will see here, if you will see the entries corresponding to this, so column 2 entry greater than the column 4 entry, column 6 entry is greater than the column 4 entry, column 2 entry 3 is greater than the column 2 entry. So when we have to compute the row min, so there is no chance to be a member of row min, to be a row min from this column. There is no chance to be a member of the row min from this column. It means we can delete this strategy. We can delete this strategy, right? So it cannot be the member of the optimal solution. So here we reduce the B2, we delete the B2 column. Then after, for the remaining one, if you will see entries for the column 1, entries for column 1 greater than the entries for the column 4, column 1 entry greater than the entry for the column 4, entry for the column 1 is greater than the entry for the column 4. It means again when we have to compute the row min, so naturally this column cannot give you the row min. So it's better you omit this, so your matrix reduced to this. So when your matrix reduced to this, so what is the benefit? Now player B has only the two player. So what is the advantage? Now you can apply the graphical solution. Now if you check, if you check the entries of the row 1 and row 3, so 4 is less than 5, 2 is less than equal to 2, 2 is less than equal to 2. It means there, when we compute the column max, there is no chance to be a member of the column max for this row, right? For this row, so it means you can you can omit this row. So as you omit this row, now we have the problem of 2 cross 2. So when we have the problem of the 2 cross 2, easily you can solve graphically now. So in this case, what will be the optimal strategy will come when I am saying that there is no A1, there is no A3. So here we have the 0, Y2, 0, Y4 will be X2, X4, X2, X4, and here we have the 0, 0, Y3, Y4, Y3, Y4 are the optimal strategy. Are optimal strategy means when we are writing the optimal strategy, yet in the final payoff there is no that strategy which we have omitted. But when we are writing the optimal solution, always we have to say corresponding probability will be the 0. Our optimal strategy, right, is strategy for player A, for the player A, and are the optimal strategy for the player B. That is the way. So with the help of the dominance rule, you can reduce the size of the matrix also. Now, last time I have explained this example to show what is the mixed strategy problem. Two players A and B play coin tossing game. Each player unbeknownst to the other chooses head or tail. Both players would reveal their choices simultaneously. If they match head and head or tail and tail, A receive $1 from B. Otherwise, A pays B $1. So when we have the head and head, so player A will get the, right, either the head or head or tail or tail. So A will get the gain of $1, and if their choices are different, then the player B will get the $1. So here we have computed the row min. So row min, and from the row min we can compute the max min. And here we have computed the column max, and from the column max we compute the min max. We compute the min max. So here you can see max min is not equal to min max. So it is not pure strategy problem, and the value of the game lie between the max min and min max, right? Max min and min max. So the value of the game lie between the -1 to 1. So when we have -1 to 1, so we assume that let associated probabilities are x and 1 minus x, y and 1 minus y. So B is pure strategies. When we have the B pure strategy, that is the head and tail. So age expected payoff will become, right, 1 into x plus -1 into 1 minus x, corresponding to tail -1 into x plus 1 into 1 minus x. So here you will get the expected payoff, age expected payoff as a -1 plus 2x, 1 minus 2x. So when we draw these two lines, here you can find that uh, x1 will come, or x will come as a half, and the value of the game will be the 0. So now we compute the B's optimal strategy. So for the B's optimal strategy also, y is equal to half. So and the value of the game will be the 0. So in this way, both player use both strategy with probability half and half, right? So that the value of the game will be the 0. Robin, who travels frequently between two cities, has two route options. Route A is fast, four-lane highway, and Route B is long, winding route. The highway patrol has limited police force. If the full force is allocated to either the route A or route B, Robin, with her passionate desire for driving super fast, is certain receive $100 speeding ticket. Means she will face the penalty, right? Is over speed penalty. If the force is split 50-50 between the two routes, means if the patrolling police, right, patrol in both routes, then there is a chance, 50% chance, she will get the punishment of $100 ticket on the route A, and 30% chance on the route B. Develop the strategy for the both Robin and police. So we have the two players. One is the Robin, another one is the police. So for the Robin, we have the choice of the route A and for the route B. For the Robin, we have the choice of route A, right, route A and route B. For the police, we have the choice of either the all police on the route A, or all police in the route B, or 50-50% in the route AB. So police has the three choices. So when we draw the Robin's payoff, so if Robin is in route A and police is also in route A, so Robin will get the penalty of $100. If Robin is in route A, police is in both route, 50-50% police is in route, both route, then there is a loss of the $50. If Robin is in route A and police in route B, there is no chance of penalty. So here the payoff will be the 0. Similarly, if player Robin is in route B and all police in route A, then the payoff will be the 0. If player B is in route, or you can say Robin is in route B and police in the route AB, 50-50% in both route, so there is a 30% chance of penalty, right? And if the police is on root B, and Robin is also in root B. So there is the chance for having the penalty, right? So now in this way generally we write the payoff. So when we compute the row min will become minus 100. Here the row min is the minus 100. So this is the this is the max min also, right? This is the max min also. Here when we compute the column max, column max, so column max will be the 0, column max will be the minus 30, column max will be the 0. So in this case, this is the min max, and this is also the min max. This is also the min max. So here we have to determine the optimal strategy for the both player. So police pure strategies, let's say police pure strategy means 100 A, 50-50 AB, 100 B. So let's say it is the 1-2-3. So age expected payoff. Age expected payoff will come minus 100x plus 0 into 1 minus x minus 50 into x plus minus 30 into 1 minus x, right? 0 into x plus minus 100 into x minus 100 into 1 minus x.
Sir,
So yes,
sir, min max will be minus 30, right?
uh, mm, min max is minus 30. Min max is minus 30, correct. This is the min max. Min max is minus 30. Still they are not equal, means it is a problem of the mixed strategy problem. So when we have the mixed strategy problem, then we have to see whether any player has the two strategy or not. Then only you can apply the graphical solution. So here we have computed the expected payoff. So when we draw this expected payoff, right? So when we draw the expected payoff, so this is the graph of the expected payoff. So here Robin strategy mix the root A and root B, right? uh, 50-50, so that the column so that the or value of the game will be the minus 50. So plus pure strategy will be the when we compute the plus pure strategy, so y1 will come the zero point 0.5, y2 will come 0, y3 will come 0.5. It means optimal strategy for the police will be means it should send all the police either on the route A or on the route B. Then they can capture the Robin for the speeding. So in this way we determine the. So today we have finished the graphical solution. In next class I will give you the idea of the idea of the linear program, how to use the linear program to solve the same problem. So just we have to write the linear program for the given game problem, right? So in next class I will give you. So uh, if possible, please revise little bit how to solve the linear program simplex method, because here I will not teach how to solve the linear program, right? So please revise the linear program. What is the artificial variable, simplex, slack variable, surplus variable, all these things. Any doubt regarding the today class, or any doubt for the quiz 2? Is there anyone who has any doubt in quiz 2?
Sir,
Yes.
so what is the date for quiz 3?
What is the
Date. You wrote Monday 22nd April, but 22nd April is not Monday.
मंडे नहीं है? 22 अप्रैल?
No, sir, it's Thursday.
नहीं, जो मंडे कब आ रहा है उस मंडे नहीं
20,
होगा
20.
देखना.
Monday is 20.
20 है
Yes, sir.
तो 20 को करेंगे, मैं कर दूंगा, रिवाइज कर दूंगा.
Okay, sir. Thank you.
ठीक है. मंडे ये तो 20 जल्दी नहीं हो जाएगा यार, 5 से 15 इसको
सर 26th is a Monday, sir.
नहीं नहीं, इसको कर लेते हैं हमारी क्लास से
Sorry,
ट्यूसडे
19.
वेडनेसडे।
19.
21 तो आई थिंक छुट्टी होगी, 22 ही रहने देते थर्सडे को।
In the
क्यों?
lecture class.
हाँ, इन द लेक्चर क्लास।
Okay, sir.
ठीक है, मैं रिवाइज कर दूंगा। मैं 22 ही रहने देते हैं थर्सडे को।
Sir,
हम्म,
sir, when we will get our mid-sem grades?
सिम ग्रेड तो हो गया यार।
Sir, not marks, grading.
नहीं, ग्रेडिंग भी मैंने कर दिया।
But sir, it's not visible on ERP.
तो मैं देखता हूँ, ईआरपी पे नहीं जाता वो, नालंदा पे कहीं हो जाता है ना। ईआरपी पे ग्रेड दिखता है ऐसे?
Yes, sir.
अच्छा, मैं देखता हूँ फिर। मिड सेम ग्रेड तो मैंने बहुत पहले कर दिया। चलो मैं देखता हूँ, अपडेट करता हूँ, कुछ कहीं रह गया होगा।
Okay, sir.
Any other doubt? So here I'm stopping the today's class.